All right, so in this video, we're going to go through some motion problems. And the first example is actually not a motion problem, but it's one dealing with geometry. And then we'll go through some motion problems as well. So to start with, the general idea of what we're going to be doing in this section is there's always a formula that we're going to be working with. And that's going to change from problem to problem. There's only a handful of problems we'll be dealing with. In this case, if you read through this example, we're dealing with the perimeter of a rectangle, okay? And so the perimeter of a rectangle is 2 times length plus 2 times width equals the perimeter. And so in this case, we want to get something that represents length and width in terms of x. So what it tells us is that it says the length of a rectangle is 2 inches more than the width, okay? So if we say that the width is x, then the length is going to be x plus 2. Then the next part says that the perimeter is 2 less than 5 times the width. And so as we're trying to figure out, kind of make sense of that, we have to get this expression where, again, perimeter, we're still going to use x, but we have to use it in terms of the width. So when it says the perimeter is 2 less than 5 times the width, perimeter is 2 less than 5 times the width. So that'd be 5x minus 2. Okay? Now we're just going to go ahead and plug these expressions into the formula. So 2 times the length, which is x plus 2, plus 2 times the width, which is just x, equals the perimeter, which is 5x minus 2. All right, so as we distribute and combine like terms, we're solving for x. So if I subtract 4x from both sides, I get x over here on the right side. I add 2, which gives me 6 on the left. So we get x equals 6. Okay? So that means that the width is 6. The length is 8. Okay? If we just double check to make sure that it equals the perimeter, well, 2 times 6 is 12, plus 16 is going to give us 28. So if we just double check to make sure that works with our expression, 5 times 6 is 30, minus 2 is 28, so it does work. Okay, so that's the geometry problem. All right, so let's go ahead and talk about the motion problems. So with motion problems, what we're going to be using is a formula that rate times time equals distance. And as we approach these problems, well, there's always going to be two different motions that we're comparing. And so we're going to create a chart where the first two columns are rate and time, and the last one is distance. And what we're actually doing as we fill out this chart is we're just filling in the information that we have about our rate and the time. Okay, we'll talk about distance here in a second. So the two things that we're comparing is we have Maria and we have Eduardo. And it says they're traveling to a business conference. The trip takes 2 hours for Maria and 2.5 hours for Eduardo. So we actually know the time for each of those. Maria is 2 hours, Eduardo is 2.5. Eduardo travels 5 miles per hour faster than Maria. So what we don't know is we don't know the rates, but if we say that Maria's rate is x, then Eduardo's is going to be x plus 5. So as we approach these problems, those are the only two columns that we're trying to fill out initially. Okay? This last column comes from multiplying the first two together. Remember, rate times time equals distance. So even though it tells us something about the distance in the problem, we're not going to use that in the chart. We will use that here in a bit. Okay? So as I multiply the two columns together, I get 2x, and then Eduardo is going to be 2.5 times x plus 5. Okay? And so this expression, the 2x, represents the distance for Maria. Okay? And this expression represents the distance for Eduardo. Once we have the chart filled out, then we're going to get an equation. And so we go back to the problem. The problem is going to tell us something about the distance. And that's when we use that to get the equation, not for the chart. So it says that Eduardo lives 40 miles farther away. Okay, so what I'm going to do to get my equation is I'm going to compare Maria's distance with Eduardo's distance. Okay, I'm going to put them on one on each side of the equal sign. Now, they are not the same distance, okay, because Eduardo lives 40 miles farther. So if we're going to balance this equation, we have to add 40 to Maria's distance, okay? All right, so there's our equation. So now we're just going to go ahead and solve for x. So nothing to do on the left side. On the right side, 2.5x, and then distribute 2.5 times 5 is 12.5. I subtract 2x from both sides, and then also subtract 12.5 from both sides, and then divide both sides by 0.5, and I get x equals 55. Okay, so I go back. X represents Maria's rate, and that's what we're trying to find. Let's make sure we're answering the correct question, and we are. So Maria drove at 55 miles per hour. Eduardo was 6 miles per hour faster, so Eduardo is at 60 miles per hour. Okay. All right, so let's go through another one. And what I would do is once I pull up the sheet, go ahead and pause the video and then try to go through it on your own. Okay, so as I do this, we have Chris, who is going to, and then also coming back. Okay, so the two things that we're comparing are there and back is how I'll label those. Okay, and so remember our columns are rate times time equals distance. What we're trying to do is just fill in the rate and time columns. Okay, so it says that she averaged 40 miles per hour there on Friday. And then returning home, traffic was wider, so she was able to average 48. Okay, so we actually know the rates going there and coming back. What we don't know is the time. Okay, and so when we return home on Sunday, because she went faster, it was 1 hour less. So what we're going to say is there is x amount of time, and coming back was 1 hour less, so x minus 1. Okay, so remember this last column on the right, we get from just multiplying these two together. So I have 40x and then 48 times x minus 1. Okay, so now in this case, when we get the equation, it's different than the first example. In this case, if she drives there and drives back, the distance is the same. Okay, so 40x represents the distance there. 48 times x minus 1 represents the distance back. Well, because it's the same distance, then our equation is just 40x equals 48 times x minus 1. Okay, so we solve for x. I'll subtract 48x from both sides. I have a negative 8x equals negative 48, which gives me x equals a positive 6. So it took 6 hours to get there, and it took 5 hours to get back. Now, on this problem, careful that you're actually answering the question. The question is not how long it took. The question is, what's the distance? And remember, this represents the distance. You could use either one, but this one's going to be simpler. Okay? So if we now know that x is 6, then 40 times 6 is 240. So the answer is 240 miles. Oh, sorry. Okay. All right, so I know this video is getting long, but we should go through one more. This one is just a little bit different, and I want to make sure that that you understand and can pick it apart. But again, I would go ahead and try this one on your own, and then watch me do it after you've tried it on your own. Okay, so two cars leave at the same point, at the same time. We'll call these car 1 and car 2. Again, we have rate times time equals distance. Okay. One car travels 8 miles per hour slower than the other. So one of our cars is going to be x, and the other one's going to be x minus 8. After 4 hours, they are 368 miles apart. So what we know is that the time that they're driving is 4 hours for both of them. And so the distance for car 1 is 4x. The distance for car 2 is 4 times x minus 8. Okay. Now, to get our equation, this is where we're going to use the 368. So they're going in opposite directions. Okay. So if you kind of get a visual, car 1 is going 4x. Car 2 is going the opposite direction, and his distance is 4 times x minus 8. Well, altogether is 368 miles. Okay. So our equation then is we're just adding the distances together and setting it equal to 368. All right, so as we solve, we get x equals 50. Okay, now let's answer the question, find the speed of the faster car. Okay, well, car 1 was 50 miles per hour. Car 2 is going to be 42 miles per hour, so the faster one obviously is the 50 miles per hour. So 50 miles per hour is our answer.